Okay, I've got a reasonably representative graph of the log base 2 function. When you estimate log base 2 of 2, well, actually, that's not an estimate. We know exactly what that is. It's 1. Okay? And, of course, on the graph, you know, the point corresponding to x equals 2 is y equals 1, right? There's a y coordinate of 1. But then we asked to do log base 2 of 3. Okay? Well, log base 2 of 3 we find by starting from 3, going up to the graph and going over, right? Now, you could reasonably draw the graph if you haven't drawn a very accurate graph, and I don't claim the mine is that great either. Come out with an estimate of 1.5, but if you think about it, you know 1.5 can't be right. It's because this point is halfway between these two, but the y-coordinate of this point is not halfway between the y-coordinate of this and the y-coordinate of this. It would be if the graph was straight. The graph is concave up, so this point is going to be more than halfway from here to here. Okay? So 1.5 is not an unreasonable estimate, but it's clearly low. And you can easily see that it has to be low. And if you estimate 1.5, then you're going to have to tell me that the slope from here to here is the same as the slope from here to here, which it isn't. So a little more subtle estimate would say, well, it's going to be more than halfway between here and here. So let's say it's 1.6 or 1.7. Okay? Now you use a similar strategy for the log base 2 of 1.5. 1.5 is here. So your y-coordinate is going to be half. You compare your y-coordinate with halfway between 1 and halfway between 0 and 1, right? The y-coordinate here is 0, the y-coordinate here is 1. So you're going to think it's not too far from a half, because this thing isn't too far from a straight line, but it's going to be a little more than a half, right? So you say it's maybe, okay, so we project up here, we project straight over here, and I project it a little low, so it looks like a half, but I know it can't be a half, right? So I fudge my estimate a little bit in terms of the curvature of the graph. And then for 2.5, well, that's going to be, that's going to be here, and we come up to the graph. Okay, that's going to be a little more than halfway between this and this. Now, if this is 1.6 and 1.7, that might be 1.4. I don't know. Okay? Okay, now look on the table. I think the table, this is problem 21, I think, yeah. Okay, you see that my estimate for 1.5 is 1.6, right? Which is fairly close. Okay, because this says it's 0.58, I said 0.6, so I lucked out on that one. My estimate for 2 was surprisingly correct. I got 1. So, well, I'll just read the graph. For 2.5, it rounds off to 1.3, and I said maybe 1.4, right? And for 3, it's 1.58, which rounds off to 1.6, right? So those estimates are kind of okay. Now there is a problem in here where I ask you to make yourself a table. Don't look at this. Don't look at the table I gave you there. That's for a different problem. Okay? And if I ask you to do that on the test, what are you going to do? If I don't have the table on the test, you're not going to be able to use the table, right? Okay? So you're going to have to draw yourself a good graph of the log function carefully. sure your points are equally spaced here and they're equally spaced here. You have to do this. Okay? It's not hard. And you don't have to be overly accurate. And if you estimated 1.5 and so forth, you know, I'd say, okay, that could be a reasonable estimate. I'd have to accept it, but I'd complain a little. Wouldn't penalize you. Okay? Now, when we get around to the final and know these graphs a little better, I'd say, you got to tell me. If you still think it's 1.5, that's okay, but tell me it really can't be 1.5 because the slope here is greater than the slope there. Make sense? Okay? On this test, reasonable estimate is accepted, and you might have to do those estimates in order to solve an equation. You might say, over there, you got log 3 over log 2, right? Or log base 2 of 3. Okay? You can always estimate a base 2 log of a number up to 4 on your basic base 2 log table that you get from inverting your columns of the 2 to the x table, right? Okay?